Let's talk about lexical this. So that's a classic job interview question. What lexical this is? Does anyone has any idea? No? It's a special keyword. That's a good starting point. Yes, that's correct. That's a special keyword. So how special it is? Let's have a look. So I'm going to create a user, player. Let's talk about basketball, yes, because of Nico. So let player, we got the first name, Michael, and we got last name, Jordan. All right. And then that object, player object, has a method that returns the full name of the basketball player, right? So I'll call it get full name, which is a function, and that function return, look, this dot first name space this dot last name. So my obvious question now is, if now at the bottom I invoke player dot get full name, what will that algorithm return? Michael Jordan, that's correct. Yeah, that's correct. I think everybody knew that, but what I'm not 100% sure if understood why, because it's not that obvious. We got this here. This, technically speaking, refers lexical this, is first of all an object. That's the first important thing. I will ask many times until the end of the bootcamp what lexical this is. So it's an object. I don't want to hear it's a string, it's a boolean, it's an object. That's the first thing. But what's the value of lexical this? It's an object, but what's the value? So lexical this refers to the object that invoke the function. So this is the function, get full name, right? Which object invoke get full name? Player. In other words, lexical this is player. That's why this dot first name is the same as player dot first name, which you immediately see that player dot first name returns Michael, and likewise with the last name. Let's try to add a breakpoint on line number 6 and see what happened. Actually, let's do an exercise. What's the execution order, guys? We got 2 breakpoints. 10-6. Lovely. It's fantastic to see that you got that. Yeah, so it's 10 and 6. Let's ignore 10. Only line number 6. Look, if we hover lexical this, we can immediately see that that's the same as the variable called player. That's why it works. Easy peasy, right? This is the most fundamental case of using lexical this. If in a job interview they ask you to create an algorithm, this is probably the most simplistic example. You got an object, you have a function inside of the object, and then you play with the properties of the object. Any questions? No? All right. Now, let's change the example a bit. This is player 1 from now on, which implies I'm going to create more players. So, I'll create let player 2 equals a new basketball player. First name is going to be Kobe, and last name Brian. Do you know why this guy is called Kobe? Why?
Oh, Kobe.
Yeah? Yeah? Well, we should ask his mother, right?
Yeah.
But it looks like, and I'm sure Nico knows this story much better than me, that their family, they went to Kobe, they tried the Kobe beef, yeah, and because of that, when the child was born, they call it Kobe, yeah. If I was there last week, not last week, obviously, last year, in Kobe, and it's definitely the best meat in the world. Prepare your wallet. That's also true. Right, so we got, sorry for the off topic, we got player 2, and now look at how exotic this is. That player 2 will also have get full name, but the value of get full name will be player 1 dot get full name. We're creating a reference to that method. So the question is, if now I do player 2 get full name, what will it return? Michael Jordan or Kobe Bryant? Kobe. Why Kobe? Yes, remember, this is an object that refers to the object that invoked the function. Which object invoked the function? Was it player 1 or player 2? Player 2, that's correct. And that means that even though line number 6 will run, that belongs somehow to player 1. Yeah? In reality, lexical this refers to player 2. In other words, that should return Kobe Bryant. Here you go, that's it. So you want to invoke player 1 to get full name, like that? No, here we are not invoking anything. We are just saving a reference. We're creating a pointer. Yes, we are not invoking anything, only creating a reference. Right, and if we do player 1 dot get full name, what will it return? Michael or Kobe? Michael, correct, because again, now lexical this refers to player 1, right? So this is very important. I'll try to avoid using this when it's not absolutely necessary. So that story is not about where the method is, it's about who invoked the method. Yeah, player 1 and player 2. Let me remove player 2 and let's do something a bit more hardcore and aggressive. So now look at what I'm doing. I'm doing get full name equals player 1 dot get full name. Oops, a reference. And now I'm going to create a variable here, a weird variable, first name, LeBron, and last name James. So now, if we invoke get full name, what will be the outcome and why, especially why? Say it again? So you think it will return LeBron James?
No, because it's not an object.
It's not an object. Ooh, that's the key. That's the key. That's the key. Yeah, but then we're invoking it. So I give you 3 options. Option A, 4 options actually. Michael Jordan. Option B, LeBron. Let's ignore the last name. You got it. Option C. Oh, sorry. 5 options. A, B, option C, undefined. Option D, error. Option E, Sule. Which one will this algorithm return?
Sule.
Sule. Why Sule?
No,
Right, not Sule.
I go for option A.
A. So Michael. Right.
Yes.
So Luigi thinks it will return Michael. Who else?
The person will say A, but
In the past. 10 years ago. Right.
I'm not using my logic, but using yours.
Yeah.
Undefined.
Undefined. So Sule said, Sule spotted something very interesting. So Sule said, hey, but now where is the object? We don't have any object. First of all, let's see what happens if we run this algorithm. That will be probably surprising. It returns LeBron James.
What is defined? First name and last name doesn't throw one
What type of data this is? It's an object. But what is the object here? We don't have any object. Or do we? Or do we? Let's set a breakpoint. Let's see what happens if we inspect the value of lexical this. Look, this is vital in your career. Ooh. By default, when you create a variable like that without any let, var, and const, that implies that's a global variable. And global variable means it's assigned to the window object. So now I'm not changing the algorithm at all. I'm doing the same thing. Window is the root object in JavaScript. If I do that, I hope it becomes a bit more predictable. Because now, who is invoking getFullName? It's the window object. Because of that, this will refer to window. This dot first name will be window dot first name. This dot last name will be window dot last name. That's why that returns LeBron James. But again, the window prefix is optional. In other words, do you remember how to delay? What happens if I want to run some code after 1 second? How do we do that? Set timeout. Every time you got this sort of functions, in reality, what you are running is window.setTimeout. So every global function, set timeout, set interval, maybe parse int, all these things, they belong to window. Yeah? But in JavaScript, the window is implicit. You can explicitly drop a window prefix, but if not, it doesn't matter because JavaScript will look after that. So now let me ask you something. And what happens if now I remove these two lines? What will this algorithm return? Michael Jordan. Michael Jordan, undefined. Who else? So the thing is, it doesn't make sense to think it will return Michael. Because again, this will refer to the object that invoked getFullName. We are not doing player1.getFullName at all. So that's for sure is not the case. So Michael, no, for sure, right? Undefined makes sense. But no, wrong as well. Error. No. What? Yes, there is. Yes. So question marks, right? Option D is the right one. Template literal. Wrong. Wrong. So I'll tell you something. Window, it's a global object. It's always there. Yeah? It's like God for the religious people, right? So window is always there. That means that unless I close the tab, unless I close DevTools, it's still there. Whatever I did on the window object will persist. Does that give you a hint about what will...
LeBron James.
Correct. That will return LeBron James, which is very weird because I don't have any single reference to LeBron James in my code. It's hidden. You agree on that? Look, LeBron James, yeah? What do you think about working with a window object or saving data into the window object? Wrong, wrong. That's an anti-pattern. This is one of the most important anti-patterns in JavaScript. And that's a classic job interview question as well. Will you save variables in the window object? Of course not. Because this is like the forest, is the wild, right? Everyone has access to the window object. Everyone can delete things on the window object. Everyone can manipulate it. Don't touch the window object. Even though technically speaking, it's possible. Don't do that. Don't do that.
Ricardo, when will that be forgotten? When you clear the console or something?
No, no. To revert the changes, I have to close the window.
Not even the console history.
No. If I close the console, as far as this window is still active, alive,
Still there.
it's still there.
Yesterday, I thought my laptop was broken because it's still giving me.
Yeah.
I'm showing.
Yeah.
It's crazy.
Yeah. And this is one of the reasons why, do you remember the curly bracket we put at the top and at the bottom every time we create a script? I'll tell you on the first day, just do it. You don't have to understand why. So one of the reasons is because at least with the curly brackets, if you create a variable, a let variable, it remains local to that closure, to that piece of code. That means that if I then remove it, if I remove player one and I evaluate again, player one won't exist anymore, thanks to the curly brackets. So that works if you put let, var, or const. But if you don't put anything, if you just put whatever, Davide here, immediately that becomes part of the window object, and then we are lost, yeah, because it will stay there forever. Of course, unless we delete it manually, which is, it's a big mess. So don't use global variables, guys. That's an anti-pattern. Any questions?
I think a good idea, a bad idea, but a good idea would be like console log.window.
Console log.window.
Yeah, because that one prints out and shows like.
Yeah, no, we can add a breakpoint. Look, if we add a breakpoint, we hover this, you can get the console of window, right? And then you can see many things here, many built-in methods.
Because it should show us all our variables.
Yeah, it will show our variables, that's correct. Look, if we scroll down, there are many things here, right? Oh, suddenly in the wing of all the core methods of JavaScript, we got LeBron, and if you scroll down, obviously we got James as well. So don't do that. Don't do that. Right, so that was the first part of the workshop. And that pattern has been valid in all the scenarios until 2015. But then in 2015, something happened. Let's talk about arrow functions. So back to the first case. So we got player one, so then we do player one dot get full name. What will that return? Michael Jordan. If you are lost, go to YouTube 15 minutes ago, because this is what we explained at the beginning of the session. So that's the first case, Michael Jordan, no problem at all. But do you think it will still return Michael Jordan if I refactor my code by replacing the classic function with an arrow function? No. What will that code return?
So it will go up one level and look into the global object.
So what will that function return? It will return LeBron James again. Look, of course. Why? Because one of the key aspects of arrow functions is that if you have an arrow function, it doesn't care which object invokes the function. It doesn't care. It's not relevant at all. With an arrow function, it will just reuse whatever the parent lexical disk was. Do we have any parent lexical disk here? Do you have any parent function? No. Because of that, what's the default object in JavaScript? Window, correct. In the browser. Because we don't have any parent context, any parent lexical disk, then the value will be window. That's why it's going back to LeBron James. Let's change the example a bit. Let's have a parent context. So player 1, Michael Jordan, but then get full name. So that will be a classic function. Look at what I'm doing now. So now, get full name will do let real player name equals first name Donald, last name Trump. And then we got another get full name. You see, we have an object inside of another object. So get full name function, and then we return that code. So then finally, we simply have to invoke the real player name dot get full name. So return. If I run that code, it's a bit hard to see end to end, but essentially I want to run player 1 dot get full name. What will this algorithm return? Donald Trump. Why Bucket?
Because it will be narrow function, so the function where you get the local lexical list.
Yep.
And the calling function is real player name.
Yep.
And object in real player name is Donald Trump.
Yeah, that's absolutely right. Bucket is right. Yep. So that will return Donald Trump. Fantastic, Bucket. So let's recap why. So we do player 1 dot get full name. In other words, if we had a breakpoint on line number 6, which because of a reason Google doesn't want me to do that. Anyway, if we stop on line number 6, in here, lexical this refers to player 1. Why? Because get full name has been invoked by player 1. So here, if we do this dot first name, it will return Michael in this line. However, we don't do that. We have another object, and then we do pretty much the same thing. Real player name dot get full name. So that line 10 is replacing the value of lexical this. In that scope, in that function, lexical this refers to real player name. In other words, this dot first name is Donald, and this dot last name is Trump. That's why, because we are simply returning that message, eventually we return Donald Trump. Does it make sense? Cool. I'll share this snippet and I'll recommend you to play with it afterwards because I think this is very important. But now let's do a couple of changes. What happened if now we replace the inner function, the real player name, with an arrow function? What will this algorithm return? Player 1 dot get full name. Michael Jordan, that's correct. Because by using an arrow function, it doesn't matter who is invoking that method. It will inherit the parent lexical this, the lexical this on the parent function. And because in that time we do have a parent function, it will take lexical this from it. And that means it will return Michael Jordan. Here you go, that's it. And what happens if we likewise do the same thing on the parent get full name method? What will it return now? LeBron, correct. Because we inherit lexical this from the parent and from the parent, right? We don't have any parent function at all. So we take it from the global scope, which is the window object. That's the way it works. Does it make sense? Yep. If we play console. Close the console, yeah. I close the console. Yeah. No, that's the same thing. Again, all right. If we close everything, let's close everything, literally. Even the tab, right? So let's be a bit aggressive. I'm not going to kill the browser, but maybe more than enough to represent that scenario. So now I'm opening the lexical this example. You can see here. What will it return now?
Now, okay, one up. So we never added in the.
Yep.
We never added because name I know does exist and all this stuff.
So what will it return, guys?
Undefined.
Who said undefined? Walter. So Walter is probably right, because now we created a new window. So this refers still to window, but now it's not contaminated by our dirty changes. So this first name is undefined. Maybe in the next version of JavaScript they add a first name property to the window object, probably not. Yeah, but unless they add the first name, actually be careful, because they do have a name property in the window object, but they don't have any first name. So this first name will return undefined. This last name will return undefined, because we have a space in between. That will probably return undefined space undefined. Let's have a look. Here you go. Walter is right. Yeah. Cool. So yeah, that's pretty much it, guys. It doesn't go much more complicated than that. I hope, thanks to that, now you get a better feeling about why, when we create a React component, we have button on click equals. You remember this dot do stuff? Why we surround our method with an arrow function? Because we want to reuse the parent lexical this. The lexical this, what's the parent lexical this? That's the class. The class. If we do that, it doesn't work, because that's evaluated as a classic function. So then, who is invoking this dot do stuff? It's probably the window object. It's whoever is, or React internally, someone, right? It's whoever triggers on click under the hood. We don't know, right? That's why that throws an error if we then try to access do stuff, because we are changing the value of lexical this. So to keep things simple, simply do that, and then you make sure that you have control on the value of lexical this. That's the actual reason why arrow functions were created 4 years ago, to simplify the process of keeping control on lexical this. And then you may be thinking, but wait a minute, was that impossible before 2015? That's not true. It was doable, it was still possible. This is what we'll learn next week. We'll talk about bind, call, and apply as JavaScript methods belonging to the function prototype. You remember the array prototype? So we'll talk about the function prototype. And thanks to bind, call, and apply, we'll be able to override the default behavior of how lexical this works. But that will happen next time, next week. So that's pretty much it. Do you have any questions?
This is only for JavaScript, there are no in other languages.
It's only for JavaScript, that's correct. Well, in other languages, they may have other sort of JavaScript, but the handling doesn't need to be the same, of course. This is something specific to JavaScript.
In Node, so global object is called global. That's the only difference.
Yeah, that's correct. That's correct. So Bilius is right. Here we're talking that the default object is window, right? But that only applies to front-end JavaScript. In back-end JavaScript, we don't have any window at all. We just have a server with white text on top of black screen, right? So we don't have window. However, as Bilius spotted, we have something equivalent with big quotes, which is called global. Yeah, actually, if you've done a bit of expert training in React, I can show that. Why are you laughing? So, if we go to the Codery platform, to be honest, let me try to figure out where that was. In the routing, yes, I think it's easier to find it in fetch. Because fetch, when you do fetch, in reality, what are we doing? Window.fetch. Yeah? Right, so this is the last part of the session. So very quickly, let me just show you one of the expert trainings. So React, and then expert. And then fetch. Yes, correct. So look, you remember I talked about Xenon or Sign-on this week. That's one of my favorite utilities to do testing. So in here, you see the way Sign-on works, which goes beyond the scope of this session, essentially. We need to provide the method that we want to mock, to simulate, and then before that, the object containing that method. So in front-end JavaScript, we do window.fetch. In back-end JavaScript, we don't have window, but we have global, which is sort of equivalent with quotes again. Right, anything else, guys? No? Cool, fantastic, that was it. Thank you.